Hi, hello, good evening, one and all. Welcome to the session. Can anybody confirm about audio and video? Good evening, friends. Good evening. Can you confirm me about audio and video? Let me check from my side. I think video seems to be fine. Hmm. All right. Sure. Right. So in the last session, we had a discussion about single phase power measurement. If you want to measure single phase power, you need to use electromagnet moving coil instrument. Okay. So called, we also call it as wattmeter. You need to design the current coil with low resistance and less number of turns. And you need to design the pressure coil with high resistance or purely resistance nature. Right. So that it is going to give you measured power almost equals to true power. But if the pressure coil will be having some inductance nature, then you will get error. So the measured power will be definitely greater than the true power, and you will get error. So we have seen the single phase power measurement and the power equation, instantaneous power. The average power also we have calculated, that is VRMS IRMS cos phi. Okay, right. And the same value is going to be indicated by the meter also. The meter is almost is going to give you the current through the current coil, that is load current, and the voltage across the pressure coil, that is load voltage, and cos of angle between ICC and IPC is around power factor angle. So the deflection of the wattmeter is proportional to load voltage, load current, and the product of that power factor component. So this is what we had a discussion in the last session. Now in this session we'll have a discussion on measurement of three-phase power. So how do you calculate three-phase power when you have a three-phase load? Let it be delta connected load or star connected load, doesn't matter. So how do you calculate? The three-phase power for three-phase load? So let us see all those things. Okay. So before moving on to the session, there's a quick recall about myself. My name is Naveen. I have around 11 plus years of experience in teaching, and I did my master's in electric power system from JNTU Hyderabad. I cracked GATE and State Public Service Commission State Public Service Commission examinations too. And here I taught more than 20,000 students since 2012. And most of the times I'll be taking electric circuits, machines, measurements, and power systems. So there's a small introduction about myself, my dear friends. Okay, can you let me know, let me know your presence, my dear, so that we can move on. So there is an announcement from BYJU'S exam prep platform. Those who have qualified, those who have shortlisted for engineering services interview. So BYJU'S is conducting mock interviews. So try to get the use of this mock interviews from the BYJU'S exam prep platform. Okay. So very good inputs will be provided by our expert panel members like Sanjay Rathi sir and Rakesh sir, Chandrasekhar sir and Dheeraj sir, Abhinav Negi sir. Okay, I think that will definitely help you in cracking the in cracking the engineering services interview examination, because they are ex ESE employees, ex ESE qualified, and they are engineering servants, to say exactly, right? So that's the small information I just wanted to put in front of you. And coming to the session quickly, let me tell you about three-phase power measurement. Okay, so if you want to calculate three-phase power measurement, let me give you a three-phase load. So if you take up the three-phase load, can be taken as maybe star connected load or delta connected load, you can take up. I am taking here a star connected load. And the star connected load, each phase is having same impedance. So you can take up ZR, ZY and ZB. So R phase, Y phase, B phase, all these impedances are equal. So ZR equals to ZY is equals to ZB. You can take up it as equal impedance Z. Okay. Now this three-phase load, we also call it as three-phase balanced load. You can take up generally this Z as lagging load. You can take up lagging load. No matter, you can take up leading load also, doesn't matter. So lagging load I am taking. Now for this lagging load, I am giving a supply, three-phase supply. So let me show you the three-phase supply here. So this is the three-phase supply, VR and Vy and of course Vb. Okay, so this is my R phase, and this R phase terminal is connected to R phase, and this is my Y phase, and this Y phase terminal is connected to Y phase, and this is my B phase, and this B phase terminal is connected to B phase. Okay, so this is how the source and the load are connected. So this three-phase balanced supply, three-phase balanced supply. Okay, fine. If you want to take the use of fourth wire, that is neutral wire, you can take up fourth wire also, no issues. But I wanted to go ahead with the three-phase, three-terminal connection. Okay, right. Now I wanted to measure the power consumption by this three-phase load. I wanted to measure the power consumption by this three-phase load. So to measure the power consumption by this three-phase load, I have to place actually three watt meters. In R phase 1 meter, in Y phase 1 meter, in B phase also 1 meter. Okay. So if I am going to place the meters, this is how it looks like. Let me show you. Okay. So here to measure the R phase power, I'm drawing like this. To measure the R phase current, I'm keeping a current coil in the R phase. And to measure the voltage across R phase, I'm keeping a pressure coil in the R phase. So it is like MC short. Now where should be this finishing terminal connected to? That generally the finishing terminal of pressure coil should be connected to the neutral, so that it can measure phase voltage, because we are connecting between R phase, and if you are going to connect between R phase and neutral, then that will give you the phase voltage. But here neutral is not available, fourth wire is not available. If fourth wire is not available, take up any other remaining two phases as reference phase. Okay, now what I'm going to do is I'm going to take up this B phase as reference. I'm going to take up B phase as reference. Okay, so now this pressure coil is going to be connected between R and B. Okay, right. Now if that is the case, now I can connect another wattmeter in the Y phase. Okay, so this is going to measure IY current, and similarly the pressure coil is connected between Y and B. Okay, so this is the pressure coil voltage. I can write it as VYB. So I cannot place 3 wattmeters to measure the three-phase power, because fourth wire is not available, that is neutral wire is not available. So I cannot measure each and every phase power. So what I can do is I can take up one phase as reference. Then you can place remaining two phases, you can place the wattmeters. Okay. Now we have to check these wattmeter readings. So let us mark this wattmeter reading as W1, and let us mark this wattmeter reading as W2. Okay. So I am mentioning the current flowing through this second wattmeter, I am writing it as IY, and the current flowing through this first wattmeter, that is current coil, so I am mentioning it as IR. Generally, the deflection torque of wattmeter is generally proportional to current flowing through current coil and voltage across the pressure coil, and cos of angle between voltage across the pressure coil and current flowing through current coil. So this is the general representation. In the yesterday we had a discussion how the wattmeter is going to give you the deflection whenever the current flows through the current coil and whenever the current flows through the pressure coil. These currents are going to create the flux lines, and those flux lines will interact and creates a torque on a moving system. Okay, so this ICC and IPC and cos of angle between them. IPC we have rewritten as VPC divided by RPC or VPC divided by ZPC, you can take up. So at most approximately it is proportional to ICC, VPC and cos of angle between VPC and ICC. That's a deflection torque given by the wattmeter. Okay. Now if it is so, now what is the deflection by the wattmeter 1? What is the deflection by the wattmeter 2? That is what we need to calculate. Now from that wattmeter readings, we might be getting the power consumption by the lagging load, three-phase lagging load. Let us check that one. Okay. Okay. So is it clear so far? If you have any doubts, you can ask me. First, I have given you three-phase balanced load. For the three-phase balanced load, I have connected three-phase balanced supply. Now I wanted to measure the power consumption by the three-phase balanced load. So to measure the power consumption, I am placing watt meters. Actually, I should place 3 watt meters, but we are not able to place 3 watt meters because absence of neutral wire. So what I am taking is I am taking any one of the phase as reference phase. So here B phase is a reference phase. B phase is a reference phase. Okay. Now let us see here the wattmeter readings. Wattmeter 1 reading will be current flowing through current coil into voltage across the pressure coil into cos of angle between VPC and ICC. This is the angle I want. What is the current flowing through current coil? It is IR, simply. What is the voltage across pressure coil? The pressure coil is connected between R and B, so I am taking it as VRB. Now cos of angle between IR or you can actually write it as VRB and IR. Okay, this is the angle between VRB and IR. Okay. Similarly, what is wattmeter 2 reading? Wattmeter 2 reading. Wattmeter 2 reading will be current coil current is IY, pressure coil voltage is VYB. We have written already. Voltage across the pressure coil is VYB, and cos of angle between VYB and IY. So this is what you need to calculate. Now, how do you calculate this IY, IB and cos of angle between this thing? Generally, the current flowing through R phase and the current entering to the load, you can see current flowing through current coil and current flowing through load, both are same. As it is star connection, phase current and line current, both are same. Phase current and line current, both are same. So I can replace this IR current as IL, and voltage between R and B terminals, I can replace it as VL. Okay, now here cos of angle between VRB and IR we need to calculate. Similarly, W2 can be taken as IL, VL into cos of angle between VYB and IY we need to calculate. So how do you calculate these angles? Draw the phasor diagram. So if you can draw the phasor diagrams, I'm damn sure if you draw the phasor diagrams you can understand the secret behind this angle, and whatever the phase or whatever the reference phase they ask you, whether they give you the reference phase as R phase, whether they give you the reference phase as Y phase, doesn't matter. Okay, right. So let us see. I'm taking here. This is my VR phase, and this is my VY phase, and this is my VB phase. Each and every phase voltage is displaced by 120 degrees phase. Okay. Now the current flowing through the load, as the load is lagging load, the current lags the voltage. I can take up the current lags the voltage. I can take up phase voltage only. So IR phase current lags the VR phase by some power factor angle. As the load is balanced load, the power factor angle I can take up it as same for each and every phase. Similarly, IY lags with respect to VY, and IB also lags with respect to VB with the same phase angle. Now what we want the angle between VRB and IR. IR is here, VR is here, and VB is here. Okay, right. So let us take up VRB. How do you take up VRB? VRB is nothing but voltage at R, voltage at B, the difference of these two. So VR is here and VB is here. Let me take up minus VB here. Because VR minus VB we want now. So VR is here, minus VB is here. Now resultant of these two, VR minus VB, resultant of these two is going to be, this is VRB. This is VRB. When you draw minus VB, the angle between VR and VYB is actually 120. When you draw minus VB, the angle between VY and minus VB is 60 degrees. Similarly, the angle between minus VB and VR is 60 degrees. And now when you draw the resultant VRB, the angle between minus VB and VRB is 30 degrees. Half now. From VRB to VR is 30 degrees. But what we want? We want the angle between VRB and IR. We know VRB where it is. We know IR where it is. Now can you tell me? Can you tell me what is the angle between? Can you tell me what is the angle between VRB and IR? Can anybody tell me the angle between VRB and IR? VRB is here and IR is here. So this is the angle we want. I can say that angle as total 30 from VRB to VR and minus 5. So it will be 30 minus 5. I can take up it as 30 minus 5. Similarly, you can do it for wattmeter 2 also. If you do it for wattmeter 2, you will get like this. VR, VY, VB, and the currents are going to be lagging with respect to each and every phase voltage. IR, IY, and IB. Here is the 5. Now, what we need the angle between VYB and IY. IY is here. What is VYB? How do you write? VYB can be taken as VY minus VB. VY is there, minus VB is not there. So let us project minus VB. Let us take up minus VB. So minus VB will be here, quite opposite. This is minus VB. And resultant of these two. So if I draw, this is going to be VYB. Now we want the angle from VYB to IY. So this angle is going to be 30 degrees. From VY to VYB it is 30 degrees. And from here to here it is 30 plus 5. Yes or no? 30 plus 5. Okay. So is it clear this one? Is this vector diagram, phasor diagrams are clear? Wattmeter 1 reading and wattmeter 2 reading. Wattmeter 1 reading will be ILVL cos 30 minus 5. Wattmeter 2 reading will be ILVL cos 30 plus 5. If you change the phase, if you change the reference phase from D to Y, then the wattmeter reading is also going to be changes. Instead of getting wattmeter 1 reading as 30 minus 5, you will get 30 plus 5. Similarly, if you change lagging nature of load to leading nature, again this wattmeter reading will change. If you want, you can check. Okay. So is it clear for everyone? Now as we got W1 reading and W2 reading, VL IL cos of 30 minus 5, W2 reading VL IL cos 30 plus 5. What I can do is let us add and subtract. Let us add it once. If you do it, if you add it VL IL cos of 30 minus 5 plus cos of 30 plus 5. 30 minus 5 plus cos of 30 plus 5. Okay. Cos A minus B plus cos A plus B. So in that way, if you do it, then we are going to get the W1 plus W2, we are going to get it as root 3 VL IL cos 5. So W1 plus W2, you are going to get this much. This is equivalent to active power, 3-phase active power. This is the 3-phase active power. So if you add the wattmeter readings, that is going to give you active power consumption by the 3 phases. Similarly, if you subtract, similarly, W1 minus W2, we are going to get it as VL IL sin phi, not root 3 VL IL sin phi. This is not a reactive power. This is not a reactive power. When will you call it as reactive power? If you multiply with root 3, then that is a reactive power. Whatever the subtraction, W1 minus W2, if you multiply with root 3, then that is going to be root 3 VL IL sin phi is a reactive power consumption by the three-phase load. So 2 wattmeter method is going to give you active power measurement and also reactive power measurement. Once you know active power and reactive power, you can calculate the power factor also. So how do you calculate power factor? Cos phi is equals to cos of tan inverse of phi. What is tan inverse of phi? Cos of tan inverse of the lower power factor angle can be taken as opposite side by adjacent side, that can be taken as Q divided by P. What is Q? Reactive power, root 3 times W1 minus W2. From the wattmeter readings you will get it. What is P? W1 plus W2. So this is the power factor measurement. This is how you can measure power factor. You can measure active power. If you add the wattmeter readings, you will get active power. If you subtract and multiply with root 3, that's a reactive power. And if you go out with this formula, you will get the power factor. So this is how you can measure the three-phase power, whether it is active power or reactive power. This is how you are going to measure active power and reactive power. Okay. If you want to measure apparent power also, you can measure apparent power. Once you get active power and reactive power, you can measure. S is equals to P plus JQ, or otherwise S is equals to P square plus Q square. This way also you can take. Okay. So remember these wattmeter readings. Remember these wattmeter readings. Okay. So here the wattmeter readings for a reference phase, B phase and lagging load. So if the load is lagging load and we have taken the reference as B for the wattmeters, then the wattmeter readings are W1 is equals to VLIL cos 30 minus phi. Wattmeter 1 reading will be 30 minus phi and wattmeter 2 readings will be VLIL cos 30 plus phi. Okay. If I change the reference phase, the wattmeter readings for a reference phase of Y and lagging load, then W1 reading will be VLIL cos 30 plus phi and W2 reading will be VLIL cos 30 minus phi. Okay. If I change the load nature, the wattmeter readings for reference phase of B and leading load. So reference phase is same B, but I am changing the load nature from lagging nature to leading nature. Again the wattmeter readings will be VLIL cos 30 plus phi and W2 reading will be VLIL cos 30 minus phi. Okay. If I change reference phase and load nature, the wattmeter readings for a reference phase of Y and leading load, then W1 will be VLIL cos 30 minus phi, same as the first case, and W2 reading will be VLIL cos 30 plus phi. Okay, so this is first case, second case, third case and fourth case is equivalent to first case. Be careful with these 4 cases. Okay, right. So be careful. I am going with the case 1 only. I am going with the case 1. Then they'll ask you the questions. Maybe from they'll be asking you to solve active power or reactive power or power factor. Sometimes they'll ask you at what power factor both the wattmeter readings are going to be equal. At what power factor both the wattmeter readings are equal and opposite. That kind of questions they'll ask you. Okay. Conclusions. Okay. So here I am taking conclusion with respect to first case. Okay, that is reference phase is B and lagging load. So I am taking power factor, wattmeter 1 reading VLIL cos 30 minus 5 and W2 VLIL cos 30 plus 5, and here are the remarks. Okay, right. So if the power factor is unity, let me go out with the unity power factor. 5 will be 0 na? 5 will be 0. If you substitute 0 here, then you will get VLIL cos 30, VLIL cos 30. Cos 30 is root 3 by 2. So W1 you will get it as root 3 by 2 times VLIL. Root 3 by 2 times VLIL. That is 86.6% of full reading. Right. Now if you add W1 plus W2, you will get it as root 3 by 2 plus root 3 by 2. It is root 3 times VLIL. So at unity power factor, the wattmeter readings W1 and W2 both are equal. Alright. Now let me take up at 30. Cos 30 will be 0.866 lagging. Phi equal to 30. If I substitute phi equal to 30, 30 minus 30 will be 0, cos 0 will be 1. So wattmeter reading will be VLIL. Here 30 plus 30, cos 60. Cos 60 will be 1 by 2. So you will be getting it as VLIL by 2. It looks like W2 is half of the W1. W2 is half of the W1. Or otherwise you can take up W1 is equal to 2 times, W2 is, W1 is equals to 2 times W2. Anything is okay. Right. Similarly, you can take up cos 60, 0.5 lagging. Phi is equals to 60 degrees. So if you substitute 60 degrees, 30 minus 60, cos 30 will be root 3 by 2 VLIL. Okay. And here if you substitute 60 plus 30, cos 90 will be 0. So this power factor will be, this wattmeter reading will be 0. So one wattmeter shows 0 reading, the other wattmeter reads the entire power. One wattmeter reads 0 and the other meter reads the total power. Okay, did you understand? Now the last one is 0 power factor lagging. At that point phi will be 90 degrees. If phi is 90 degrees, 30 minus 90, cos 60. Cos 60 will be 0.5. So VLIL by 2. Okay. Now similarly here 30 plus 90, 120. Cos 120 will be minus, you will get minus VLIL by 2. So at this point I can say both the wattmeters are equal and opposite. So W2 is equals to minus W1. Okay. So they'll ask you at what power factor both the meters will give equal readings. At unity power factor. At what power factor they'll give you, both the meters will give you equal and opposite at 0 power factor lagging. Okay. At what power factor one of the wattmeter reads 0 reading. At 0.5 power factor. Otherwise 60 degrees angle. At what power factor both one wattmeter reads half the other. It's at 0.866 lagging power factor. Okay. So this conclusion is with respect to case 1. If I go with case 2, then this becomes W1 and this becomes W2. Okay. W1 will be W2 and W2 will be W1. So these are the very, very important conclusions you need to remember. On this, definitely one question will be there, and ESE and GATE. Every year one question will be there in ESE and GATE. Maybe most important topic I can say. Okay. So that was the discussion about three-phase power today. If you have any doubt, you can ask me. So here it is, there is a crash course announcement. The crash course is not just for ECE but also for EE, mechanical and civil also, CS also. So this crash course is meant for to brush up your concepts and to strengthen your fundamentals. Okay, so here we are going to teach more of theory oriented. Through the problems, we will be take up some problems also, right? So if you are interested to join, you can join. And this is my Telegram channel where you can ask me doubts or any suggestions. If you want any PDFs or notes or any support, you can ask me on this Telegram channel. Okay. So if you are very much new to the BYJU'S exam prep platform, please try to subscribe and hit the like button and bell icon to get the notification from the BYJU'S exam prep YouTube channel, so that whatever the notification or whatever the updates which we are going to provide, that updates you will not miss. Okay, most of the updates we are going to we are going to give with respect to GATE and ESE oriented only, and PSUs also. Okay, so all these notifications are related to your career opportunities and higher educations only. Notifications about higher education and career opportunities. Okay, right. Of course, this kind of free sessions also will be provided, right? So in order to give you idea about BYJU'S exam prep platform, how we are going to teach and how we handle the subjects, right? These are just if you want the remaining cases also, like case 2, case 3, case 4, we will be solving that case 2, case 3, case 4 in the paid classes. Okay, if you like our promotional classes, please come and join with the BYJU'S exam prep platform. Okay, if you have any doubts, you can ask me. Chalo then, have a nice day. Bye bye. See you.